All right, this is a back page of additional notes for integrals involving position, velocity, acceleration. So we start off, this example provides us the derivative graph, the velocity graph for representing, we can say f prime of x. And so if we're looking at f prime of x, we can create sign lines, and we can identify sign lines for slope as well as sign lines for concavity. So positive slope will be regions above the x-axis. Negative slope represents regions below the x-axis. So we can create our sign line. Critical point is at 1, and then 0 and 4 are the endpoints. Negative slope below, and positive slope for the regions above the x-axis. And to find critical points for second derivative, we can determine concave up and concave down. Concave up would represent where we have positive slope for f prime, so concave up. Okay, it's going to hit a maximum, so that's going to be a potential point of inflection. And then it's going to decrease, so we have concave down. Okay. Okay, so to kind of help with the analogy of to kind of visualize what these area under the graph will represent in terms of velocity, let's say we have a vehicle that is on the highway, and we assigned a positive direction and a negative direction. Okay, let's say positive direction represents where the mile marker is increasing, and negative direction would mean that the car is moving in the direction so that the mile marker is decreasing. Okay, so it's on the highway, and let me just kind of highlight what's happening with the motion of this car. So when the timer starts, the object, this car, is going to start at a certain point, but it's going to be moving in the negative direction. Okay, because we have negative slope, we have negative velocity. Okay. So think of positive velocity as moving in the positive direction where the mile marker is increasing. Negative velocity means the object is moving at a speed so that it's moving in the opposite direction where the mile marker is decreasing. So, so this region, this object is moving in the negative direction, and then it's going to stop. Right, this is where velocity is 0. Turn around, and it's going to start moving in the positive direction. Okay. But while it's moving in the positive direction, the slope is increasing, so concave up represents that this car is accelerating as well. Okay. So it's moving in the positive direction, but keeps accelerating, and then hits a point where he starts to begin decelerating, but still moving in the positive direction. And then we stop the timer at 4. Okay. Now, the distance that he covers is based off of the area between the x-axis and the curve. So for instance, let's say 1, 2, 3, 4 on the x-axis represents minutes in time. So this object is going to move in the opposite direction for 1 minute, and he's going to go opposite direction for 1 mile. He's going to stop, and then from minute 1 to 2, he's going to cover 1 mile. But from 2 to 3, he's going to cover 3 miles because he keeps accelerating, right? So he's moving at a faster and faster velocity, allowing him to cover more distance in the same amount of time. Okay, but then after the 3rd minute, he's still moving in the positive direction, but then this car is decelerating. So over the same period of time, it's not going to cover as much ground. So we're going to go ahead and find the area. The way we find the area, we simply go through geometric formulas. So all these are triangles. The area of this region is 1/2 base times height. So 1/2 1 times 2 is 1. 1/2 base times height, 1/2 1 times 2 is 1. To find this region, we can do 1/2 base times height. So the area of this triangle here is 2 times 4 times 1/2. So we know this entire region is 4. So if this is 1 and this entire region is 4, then we know this must be 3. And then to find the area of this region, from 3 to 4 is 1, and then base times height 1/2 base times height, so 1/2 1 times 4 gives us 2. Okay. Okay, so for part A, find the x-coordinates of all relative extrema and justify your answer. Relative extrema is going to be where f prime is going to go from decrease to positive, so we know that x equals 1 because f prime changed from negative to positive. Find the x-coordinates of all points of inflection, so we simply look at f double prime graph, there's a change in signs, so x equals 3. Okay. So now, going back to the analogy of mile markers, let's say, okay, f of 0, okay, if f prime represents velocity, then we know f of x represents the position. Okay. Now think of it this way. Okay. Let's say the object starts at mile marker 1. Okay. Where is the object going to be after 1 minute? Okay. So at time 0, from 0 to 1, he's going to be moving in a negative direction. So if he starts at mile marker 1, and if he goes in the opposite direction, then you know that after 1 minute he will be at mile marker 0. And that's exactly what f of 1 is. F of 1 allows us to take the starting position, f of 0, figure out how much distance he covers looking at the integral of velocity, and then how much distance it covers, and we add it to our initial position, so 1 minus 1 equals 0. So f of 1 is equal to 0. So think of f prime as his velocity, the speed that he's going between 0 and 1 minute. So through this, finding the area, we figured out that he's covered 1 mile, but moving in the negative direction. Okay. So now if we want to figure out where is this car going to be after 2 minutes, then we know that at 1 minute he's going to be at mile marker 0, and then we can figure out by looking at the area how much ground this car is going to cover between the first and second minute going at this particular velocity. However, we know that the velocity is changing because the slope keeps increasing. So this car is going to keep increasing in velocity, but we can simply look at the area to figure out how much distance he covers. Okay. So if he's at mile marker 0, and then from 1 to 2 he covers 1 mile, then we know that he will be back at mile marker 1. Okay. To find his position at in the 3rd minute, we know that from the previous result that this car will be at mile marker 1. But then he's going to keep increasing in velocity